everyone, today we're going to talk about log functions or log equations. This is something totally different, totally new. I know it's going to seem kind of foreign to you, and I'm totally bummed that we don't actually have class today for me to be able to walk you through this step by step. So we're going to do that through this video here. Excuse me. But there's a lot of little kind of pieces and parts, but I promise you once we do some examples and you kind of see where everything goes, it's really not that difficult. And I know it's going to seem really, really weird at first, but just stick with me. I promise you it's all going to be okay. All right, so let's talk a little bit about this. Log is short for logarithmic. Logarithmic. And logarithmic is just a fancy way of saying exponent. Truly, that's all it is. Okay, when you break it down to its simplest form, that's what it means. So let's first talk about an exponential equation. Exponential equation. So let's say, for example, I have the equation 3 squared is equal to 9. It's my exponential equation. Over here, I have log equations. And I'll show you how they relate in a second. Before I do that, I want to talk about some terminology. 3 in this particular problem is your base, and 2 is your exponent. So we say 3 is the base, whose exponent is 2, that gives you 9, right? That's one way we could say this. We don't say it like that, but we say 3 squared equals 9, but if you really wanted to break it down into its most basic form, you can say the exponent whose base is 3 that gives you 9 is 2, right? And that's a convoluted way to say it, but you can say it that way. Let me show you how you would actually rewrite this same exact equation in log form. This is actually really, really cool. First of all, you're going to use the word log in your equation. Okay. The next part we talk about is this base of 3. Because it's a base, we actually write it as a subscript. The next part we write is that number, and we say that's equal to our exponent. So our exponent goes on the other side of the equal sign all by itself. So we're going to do a bunch of examples to get you used to this, but let me tell you what this says. This says the exponent whose base is 3 that gives you 9 is 2. Okay. 3, let me do this in a different color. Well, if I can get my little pen to work. Okay. 3 is my base, so 3 squared is 9. The exponent whose base is 3 that gives you 9 is 2. That's what this is saying. These two equations are equivalent. So notice where the pieces go, right? There's only 3 numbers in this equation. There's only 3 numbers in this equation. They're in different spots, but recognize where they go. This is your base. 3 is your base. It's written as a subscript. 2 is your exponent. It's written on the other side of the equal sign. This answer here, 9, is what this is right here. I'm sorry that I keep coughing. Let's do a different example. Let's say 4 to the 3rd is 64. Okay, if I write that as a log equation, or if I write that in log form, get a different color here. I'll say log. Now my base in this problem is 4, so that's my subscript. Log 4 of 64 is 3. You can say log, and the way you say this is log base 4 of 64 is 3. The exponent of 4, that's 64, is 3. The exponent of 4 that gives me 64 is 3. Okay? These two equations are equivalent. Let's try another one. 5 squared is 25. If I write that as a log equation, so if you want to try it yourself, pause the video for a second, see if you can figure it out. Here is this as a log equation. Log base 5 of 25 is 2. That is how you convert from an exponential equation into a log equation. It's just another way of writing it. And you might be saying, well, what the heck am I doing this for if I already have it in the other form? We're going to get into that as we go through this unit and the next unit. But this is going to help us to solve problems that we couldn't solve before. It's going to help us to do things that we weren't able to do before. It's actually really cool, and there's a lot of fun little tricks and little kind of things you have up your sleeve that you can use to kind of figure out these problems, okay? But that's going from an exponential equation into a log equation. Let's go ahead and go in the reverse order. So let's say we're starting with log equations. And so here's my log equation. And now I want to convert it into an exponential equation. So I'm abbreviating here. So I'm going from a log equation to an exponential equation. So let's say I have 10. Oops, actually, hold on, I'm writing the wrong thing. Okay, I want to write it in log form first. So I'm going to say log base 10 of 1,000 is equal to 3. Now, I want to convert this into an exponential equation. The first thing I need is my base. My base is my subscript. Well, that's 10. The next thing I need is my exponent. My exponent is what's on the other side of the equal sign there, and that's 3. And then that's equal to 1,000. Right? These two equations are equivalent to each other. Let's try another one. Let's go with log base 7, 343 equals 3. Can you put it into exponential form? See if you can do it. Give it a shot. Okay, my base here is 7. This is my exponent is 3, and that's equal to 343. That's how you switch back and forth between the two. Now, we just did some very basic examples. Let me show you something else about this that's actually really, really cool. And you're probably going to go, oh boy, there goes Mrs. Lee saying that something's going to be really cool. This also works if you're talking about square roots or cube roots or anything like that. Once upon a time, you should have learned that when you talk about the square root of a number, so the square root of 4, I can actually write that as 4 to the 1/2 power. Right? If I'm talking about the cube root of a number, so the cube root of 125, that's the same as saying 125 to the 1/3 power. That's an exponent there. 1/3 is an exponent. Actually, I should rewrite that so it looks more like an exponent. So when you're talking about exponents and you have a fractional exponent, the denominator of that fraction is always the root that you're taking. Okay? So I can take this term 4 to the 1/2 and I can actually write it in log form. I can say log base 4, if my exponent is 1/2, then, and I don't have it written here, but what number goes here? Well, what is the square root of 4? The square root of 4 is 2. So 4 to the 1/2 power is 2. That's all that is saying. So if you see a fraction over here as your exponent, all that means is that now you are taking some sort of root as opposed to raising it to some power. Okay, that's all that means. Let's look at this one. The cube root of 125, right? This is actually equal to 5, but let's write it in log form. So I say the log, right? I can say that my base here is 125. And I can say that my exponent is 1/3, and then my answer is 5. Okay, so that's just another way of writing it. It's just another another example of a different type of a log function that you might see. Okay, so I wanted to show that to you as well. Let me give you a couple of other little helpful hints that are going to help with your assignment. Whenever we're talking about logs of base 10, right? So if I have 10 to the first, that's equal to 10. 10 squared is 100. 10 to the third is 1,000, right? And I think you can see the pattern here. That exponent is basically just telling you the number of zeros that you have, right? And so you can keep going. Whenever you are writing log functions and you're talking about base 10, you don't need to write the base in there. So I would actually rewrite this as the log of 10 is 1. I would rewrite the second one as the log of 100 is 2. I'd rewrite this as the log of 1,000 is 3. Anytime you don't see a base, okay, anytime you do not see a base, that means it's base 10. Right? Notice here all of these are base 10. Okay, anytime you see a log written without a base, that means it is base 10. So this is the assignment that you are doing for tonight's homework. Okay, you'll see the first 3 problems here. You're just going from exponential to log form. These other ones, 4, 5, and 6, you are converting from log form to exponential form. Now, these are asking you to figure them out. So take it out of log form and put it in exponential form. Let me show you what I mean. Let's look at problem number 10. Problem number 10 is log base 4 of 16, and they're asking you to figure that out. Okay, so log base 4 of 16. Well, what is that equal to? I'm going to call that x because I don't know. So it's basically saying 4 to what power gives me 16? That's what this is asking you. If I don't write this at all, right, this is all they gave you in the problem. All I'm saying to myself is, okay, this is my base. So 4 to what power gives me 16? I know then that answer has to be 2. That's how you're going to figure out those problems. So it's pretty straightforward. I want you guys to give those a shot. The last couple problems on the assignment are graphing. They gave you the exponential function and then the numbers to use to graph it. Talks a little about the inverse. Give those a try. I will have another video for you to sort of review before the quiz that's coming up on Friday. All right, everybody, have a great day. We'll see you later. Take care. Bye-bye.